Well, good morning. Thanks for having us. I'm Brad Schmidt. I lead the CloudTAK program for the State of Colorado Department of Public Safety. We are here to talk about the other CloudTAK today, but just wanted to give a little bit of context before I turn it over to my developer, Nick. So we've been doing R&D into the Team Awareness Kit for several years. In 2022, we received funding from the state of Colorado to build TAK out as an operational system for public safety for any type of first responder within the bounds of the state of Colorado that wants to use TAK. We also received a grant from the Federal Forest Service, the USDA Forest Service, that same year to build a similar project for them to deploy with wildland firefighters nationwide. That's called WFTAK, or the Wildland Fire Team Awareness Kit. So those two projects are really the genesis of our requirements for building out CloudTAK. Before we get into that, though, specifically, some of the kind of principles that we've been working off of that should chime with what the other speakers in this track have been speaking about are really the importance of us, using off-the-shelf TAK products. And really, when I say a TAK product, I mean the baseline core TAK products. As Texas DPS, I think, really did a great job of speaking to, plug-in management is a huge challenge for us in public safety. And really, as you can see on this pie chart, the majority of our users on the COTAK system, at least, are iOS, and so they can't even access any sort of ATAK plugin. So being able to accomplish our missions using the core TAK products really eases the burden for allowing our users to actually make use of TAK operationally. And so really, along with that, we've been focusing on just the basic features of TAK, blue force tracking, knowing the locations of our friendly first responders, and then enabling interoperability. And that's really been the key thing. Is some of our larger urban public safety agencies are starting to field mobile systems for blue force tracking and mapping of public safety incidents. But with those proprietary solutions, they're typically only able to see their own agency. And what happens when two agencies need to work together? What happens when all 20 agencies in a county need to work together? Or even a larger disaster occurs where folks are moving across the state to help. And that's where unifying people into TAK and making TAK interoperable through our CloudTAK project has really paid dividends, and that's a huge value proposition when we go to pitch TAK to a fire department or a police department. Some of the other really important core principles for us are to use as much as possible just streaming COTS and data sync as our method for disseminating data out. And then avoiding plugins, MDMs, other barriers for adoption. So that's how we've been kind of sticking to some of these principles as we build TAK out, and then deploying all of our code into AWS GovCloud operationally. So COTAK, we began building that out in 2022, and we received permanent funding for the program in 2024. So we are now a kind of program of record, as it were, of the state of Colorado, at least, to deploy TAK out. And really what we're able to achieve with all this is any first responder, whether they're a search and rescue volunteer, state police, firefighter, they can access TAK free of charge. They go to cotak.gov, which is our website, they sign up, they're able to get a login to TAK and begin using it operationally. So at a high level, this is what our system looks like. We, of course, use ATAK-Server as kind of the core of everything. And then we have built a custom web application, which I'll just touch on very briefly in the next slide. That is our user management system. So if a fire department or police department signs up for COTAK, we get to designate one or two of those first responders as an agency administrator for their department. And they are then able to create the accounts for all of their first responders. They're able to program channels, and all of that information is then written into an open LDAP server, and that is what TAKServer authenticates against for us. We do federate our TAKServer with other TAK servers to achieve that interop with our federal partners, and in the future, potentially other states that are neighboring us. And then we built CloudTAK out. And really, CloudTAK, we'll brief what it is here. What you're seeing here is just kind of a part of it, which is our ETL server of being able to bring data into TAK and out of the TAK ecosystem. So things that public safety cares about, like the locations of body-worn cameras, the locations of 911 dispatch calls, and then bring data out into external systems like ArcGIS. So that's part of CloudTAK. We also are a web front end for TAK, but we'll show you all of that here in just a second. But just to touch on it, this is what the user management system looks like for TAK. And really just want to show this slide to foot stomp the importance of TAK channels. TAK channels allow each end user that is using ITAK or ATAK to turn on and off. It really is a TAK-Server group under the hood. It allows our users to filter what data they want to see in real time. So that prevents data overload, and it also enables that interoperability. So a fire department, for example, they might start the day on a channel where they're just seeing other fire units within their city, but they have access to a county or a metropolitan mutual aid channel where, okay, now we've got a wildfire breaking out. We are having help from other fire departments around us arrive. I want to turn on a channel in the app just by pushing a button in ITAK or ATAK, and now I can see all of those resources from other counties, and then that scales all the way up to the state of Colorado for mutual aid across the state. We're doing something very similar in the WebTAK system. We actually link to the federal dispatching system, so we're able to see when a federal firefighter gets sent to a large wildfire. We know that information, can automatically give them access to a TAK channel associated with that wildfire. So that's just a quick touch on the user management side of what we're doing. But let's get into CloudTAK. So just a little bit of where the state of the art is for ATAK. We have an ISR aircraft program in the state of Colorado. We just got Starlink installed on it, and now for the first time, we're able to stream live video, live FMV from that aircraft down to TAK on the ground. So that's a quick clip of what it looks like in ATAK. But what if I don't have ATAK? What if I'm in a dispatch environment or an emergency operations center? I've got laptops probably, but they're super locked down. It would take me weeks to get IT to let me put WinTAK on them. I want to see that information in a web browser. That is really the genesis of our requirement to build out CloudTAK. And this is an example of seeing basically that same data through a web browser. So this is looking in Firefox on the same wildfire. We're turning on a data sync mission here. So you're able to see a bunch of polygons that were hosted in a data sync mission. I'm also seeing some streaming COT markers on the map, and I'm able to save my live FMV feed all within a web browser. So that has been the transition that we've made as we've built out this CloudTAK product to not only be that data interoperability capability, but also to be a fully functional web-based user interface for TAK. And so with that, I'm going to turn it over to the guy who made it all happen. Let's give it up for Mr. Nick Ingalls.
Hey everyone, my name is Nick, coming originally from the private sector with Mapbox, so I have a long history of building web-based geospatial tools, and somehow a couple years ago Brad managed to get me to take a pay cut and move over to the public sector, and I haven't looked back once. So CloudTAK comes from the need, like Brad said, for first responders to be able to access these tools in the web. And with an expectation of the first responders' expectation that cloud tools essentially work like Instagram. They're intuitive to use, they're beautiful, and they just work. So a little bit background on CloudTAK. CloudTAK's 100% open source. There's no cost associated with it. So I'll include, I think, at the end a link to our GitHub. Everything we've done is available for you to use in your TAK program. So CloudTAK started with the need for an extract, transform, and load server to load arbitrary geospatial data. We wanted to do that in a cloud native way, in a way that's both scalable and monitorable, so that we could easily see if a data integration broke and actually kind of respond to fix this. So originally, CloudTAK had no kind of web like map UI. It was entirely focused on converting data to and from TAK and passing it in and out of the TAK server, based on essentially, like we called it a cloud EUD originally. And then we started building out a GUI to actually be able to to handle the incoming and outgoing data, essentially doing field mapping from external systems into the cloud. And being able to push them into kind of any of the TAK native data locations, so either directly into the connection, into a data sync, or into a data package. This early work kind of blossomed into many kind of ETL functions. You'll see names of a lot of kind of the public safety, the external public safety services that are common for our users. This is a small snapshot of some of the data providers, the external data providers that we can bidirectionally pull or push data to and from the TAK ecosystem. Oh, is the video going to load? Oh, okay. Uh-oh. Our video is not going to load. All right, we'll just go into a live demo because the video is not loading. Are your login credentials on here? I don't know why the video is not working. Let's see if that. Oh, we're gonna have internet problems. Oh, there we go. All right, so we'll just go into a live demo. So bear with me. This was a little unplanned, but so we're going to show you off kind of a feature demonstration of CloudTAK. I'll start with the original extract, transform, load infrastructure, and then we'll move kind of into the web front end. So we'll bear with us as this loads. The internet here has been a little slow. Cool. So on the back end, we can see right here our incoming layers. Layers are managed as part of a connection. That's kind of the EUD in a cloud. When we create a new connection, we have the ability to give the connection a name, decide whether it's a cloud integration or an external integration, which will generate your P12 credential files that could then be loaded on something like a Skydio drone. Give it a description. We can connect it with an agency. And then we can assign users to a channel. So let's say we're doing this for Mesa SAR. I could then go through and choose the channels that I want this connection to be able to push data through. So since it's Mesa SAR, I probably want the Mesa SAR channel. Oh, it's because it's my agency. So we'll say all users. I'd hit create channel. I'm not going to create this because this is our production infrastructure right now. Eventually, once it finished configuring, it would create a container with a persistent TLS connection between our AWS cloud and the server and be ready to kind of accept data. So this will spin up an API to allow external data providers to push data directly, and then it also allows us to deploy cloud Docker images to perform that ETL function. So these are examples of different ETL functions that are running as AWS Lambdas and are going to run on one of several invocation types. It could be on a schedule, it could be in response to a webhook, it could be in response to an email, and pull data from that external system and then push it into CloudTAK. We've got a list of channels that this connection is associated with. And then we've got files, data syncs, videos, and API tokens. So I'm going to jump straight into one of the connections. We'll take a look at the inReaches. So when we create a new layer, we're dynamically provisioning cloud infrastructure. So under the hood, CloudTAK will write CloudFormation templates and then deploy them via the AWS CloudFormation APIs. So in this case, the inReach is a relatively simple one. It's creating a Lambda from an ECR repository of Docker tasks. Spinning up that Lambda and then configuring all of the environment to speak to this particular CloudTAK instance. So kind of similar to the Canadian CloudTAK, we see a lot of tightly coupled cloud integration on the ETL side. We can set up the different invocation types. We can set up the environments, for example, of what data that we're pulling from. We can see the schema or the shape of the data coming into CloudTAK. And then finally, we've got a full field mapping application where we can then map the fields of the incoming data into a cursor on target format. The cool thing about the ETL structure is CloudTAK doesn't care about what data is coming in. The ETLs register what we call a capabilities document to say this is what I need to run and this is what I'm going to produce. And then CloudTAK dynamically generates a UI to get those things from the user and then push the data back out. So generating a new layer, let's say you wanted to pull from let's say a military system, from NATO data, you wanted to add VMF. That's the binary format that you hear a lot about on the military side. Generating a link to that would be as simple as writing an ETL saying, hey, I need this, a connection endpoint to connect to, and then we have a data contract saying, hey, this is what you need to give us. So each of these UIs looks a little bit differently, just based on whatever that capabilities document is registered. Yeah, so they can be pushed both to directly into a connection, so kind of real-time streaming data, AVLs or officer locations would be an example there, or we can also push data into a data sync, and then CloudTAK will perform the diffing operations to synchronize the external data set with the data sync. So right here we've got CAIC avalanche forecasts, which are useful for our backcountry search and rescue teams. So every hour we go out and check the avalanche forecast and then sync that back in. We can also do that bidirectionally, with something like AGOL. Oftentimes our wildfire analysts are, they're doing analysis on the AGOL side or ArcGIS Online through Esri. So we can also pull in their data products and then push out our real-time locations to Esri or to an external system. We support both incoming and outgoing data from the TAK server, and they're both managed in those Docker containers. So we're agnostic as to where we're pushing data. Anything else I should touch on the ETL side? Cool. So that's the ETL side. That's mostly managed on the admin side. Where kind of CloudTAK started to go a couple years ago was I needed a debug interface and WebTAK wasn't cutting it. First responders would log into WebTAK and it wasn't a modern interface. It didn't feel like Google Maps is really what it boiled down to. So I started building a web interface a couple years ago just for my personal kind of debug sessions to see data flow coming in and out of TAK. And since then it's become our primary common operating picture for web-based like TAK viewing. So oops. So I'll just real quick go through a couple of the tools that we expose. So first off, we've got your features. We've got full support for archived features. You can create and manage your own geospatial features in the cloud. We'll take a look at here's a special weather forecast that we drew. And manage these in folders or export them as GeoJSON or KML for use in an external system. We've got full support for overlays. So CloudTAK will dynamically tile external data sources. Esri, for example, their feature and map servers don't support vector tiles natively. Under the hood, if you drop in an external data set that CloudTAK's familiar with, it'll go through and generate a tiled data layer for it, and then serve it over the web via a tiled approach. So if you're hitting an imagery source stored in an image server in Esri, we'll go make the bounding box requests needed to serve that as tiles, and the same for vector data. On the fly, we'll convert that to vector tiles and serve that via the browser. Also got support, for base maps, and we can do file-based imports. So if a user has a GeoPDF, which is pretty common in the wildfire world, we can import and display GeoPDFs, and we've got data syncs and data packages here as well. So I can go in and add any of these are some of our global kind of global layers, and then also upload any of my files. So on the file side, one of the challenges of web geospatial is your browser can only take so much. I don't have access to the full capabilities of your machine. I'm limited by what the browser provides via API. So when a user uploads a file or data asset into CloudTAK, on the hood we spin up a data conversion process that, just like we do the dynamic tiling, will convert your uploaded file into a cloud optimized format. So for example, for raster imagery, we would convert that to something like a COG, a cloud optimized GeoTIFF, that is internally tiled for more efficient serving to the web. Or for something like vector data, we'll convert it to GeoJSON as an intermediate format, and then get it into vector tiles, so serving vector tiles over the web. We use the PM tiles format. It's kind of a modification of MB tiles, and it allows for byte range requests into S3. So we can serve large geospatial assets in S3 from a single file at very low cost. It costs us pennies to convert and then host these files. So contacts, we've made improvements on kind of the native contacts tool. In Colorado, we have a schema for first responders, but based on color. I know Texas is doing the same thing. So we have the ability to kind of load in some of our structure information, so that users kind of know what users are coming from where, and the ability to chat with them in the field using just the built-in TAK chat. Got support for base maps. Like I said, we can load raster base maps. We also have full support for vector base maps. So ATAK and Chris Lawrence have been doing a ton of work on open map tiles. We also have full support for vector-based imagery layers. There we go. So this is open map tiles running as a base map. It doesn't matter what the vector tile source is. If you give me a style sheet, we'll use it. So if you're using proto maps, for example, we can use proto maps. If you generate a base map in Mapbox, no problem, we'll pull that in. Full support for data sync. Data sync is like one of our most crucial use cases. From a cognitive understanding of TAK, conditional delivery is really hard to explain to our users. It's really difficult for them to not understand why, when they share a point in ATAK, it may or may not get to the user they intend. So we're very heavy users of data sync as it solves that conditional delivery problem. It guarantees delivery the next time the target device is on the network. So within CloudTAK, we have full support for editing and managing data sync missions. If you notice the mission mode up here, once I make a mission active, it changes the context of what I'm doing in CloudTAK to be editing my own features to editing features related to the mission. So once I'm in a mission and it's been loaded up in that upper left-hand corner, all of my map interactions, my data creation will apply to that specific mission and be automatically shared out with my users in the field. So I can see here layers related to this particular mission, which was an evacuation. I can see users that have subscribed. I can see a timeline of the changes. Oh, something is amiss. That's live demos for you. I can generate mission logs. One of the things FFmpeg just added Whisper support, so we'll be able to pump in things like real-time transcriptions of radio traffic into your data sync mission, and then full support for files. And I know I'm starting to get slow on time. Full support for channels, like Brad said, we're heavy users of the channels tool, so it was really important for us for users to be able to go in and turn on and off channels. The video server is one of the really interesting ones. So CloudTAK comes backed by a video server. So we will dynamically provision media infrastructure to remux streams to be supported in a browser context. So one of the biggest challenges that we had with the original kind of core TAKServer is that most ATAK data is coming in for video streams is coming in over SRT or RTMP or RTSP, which aren't browser compatible. So we'll dynamically grab that stream URL, provision media, provision space on our media server, and then stream that out as HLS. And you've seen some videos from the MMA with what we're doing there. Chat is chat. Route generation, so this is a relatively new feature we're starting to get into where we have snap to route or traditional directions API integrations. So I can go in and generate a new route, which I can then blast out to users. ATAK especially has been getting, their route navigation tools have been getting better and better. So then a user can open it up as a native TAK route object and route along it. And then, yeah, I've already talked about uploaded files and obviously icon support you can see. So that's a pretty brief overview of the functionality itself.
Let's see if we can do deployment.
Yeah, it should work. So deploying CloudTAK, we have two main deploy targets. The first, as especially in public safety, not everyone has access either from a funding perspective or an IT perspective to AWS infrastructure. So we do target Docker Compose as a deploy target for CloudTAK. Our goal is that all of the map-facing functionality will remain entirely compatible within a generic kind of Docker Compose context, and then it can be easily spun up on a DigitalOcean droplet or a traditional kind of Cloud Light host or a physically provisioned infrastructure alongside the TAKServer. The ETL system is AWS native. There's no plans to change that to a Docker context. So the first part of the presentation where I showed all the ETL systems. Gotta find something else if you're doing physically provisioned infrastructure. There's been a lot of good work in Node-RED, for example, in the public safety community. But the map functionality we do support in Docker Compose entirely. And the last roadmap item, which I should have released this week with CloudTAK 11, will be user file processing will work entirely in the Docker Compose context. So that'll mean that that's the last kind of AWS-specific functionality in the map view. So when you upload a file or import a data package, it'll do all that cloud optimization within that Docker Compose context. More exciting deploy, more kind of full deploy of CloudTAK involves AWS. Everything we do as well at the state side is infrastructure as code. Our TAKServer is running on ECS with powered by CloudFormation. Same with CloudTAK and our media server. It's a one-click deploy to be able to go from nothing in your AWS account to a full CloudTAK deployment. So right here you can see a little bit of the infrastructure. I won't dive too deep, so we have a few times for questions. But you can see here we use a lot of the kind of core building blocks in AWS to provision our infrastructure and be able to scale horizontally to thousands of users during an incident. Cool. I'll open the floor to questions. I can jump back into the live side of things if folks want to see something, or if you have kind of high-level questions, I'm happy to answer them.
And there's our emails, too, if you'd like to shoot us a note offline.
Cool. You guys are making life easy. Yeah, shoot. Mm-hmm. Yep. And then all of a sudden I want to connect back to CloudTAK, upload, pull some information back down, how that process works. Yeah, so right now we don't have, we haven't built out any sort of backfill operation. That's certainly something we've talked about. In the public safety, CalTopo has been mentioned a lot. And one of the kind of features that some folks view as key, some folks don't, is their ability to kind of upload historic tracks when they reconnect to the internet. There'd be no reason CloudTAK couldn't provide an option for that, but it's not something that we've built out to date. We've certainly talked about it and doing something like having a plugin in ATAK to upload only points that are already staled out and have the TAKServer intelligently not route those to active users in order to backfill the database. But it's been a conversation. It's not something that we've actually taken on work-wise. So we're primarily focused on connected clients. Yeah.
Another round of applause for